Do you know what equivalent weight means and how to calculate? Let me explain. Equivalent weight is simply weight divided by valence. What is different is that both these components are at an atomic level. Dividing the atomic weight by valency provides a way for us to standardize 1 mole of different substances so that we can compare their interactions. Let's break that down starting with 1 mole. 1 mole of any substance is whatever amount that contains an Avogadro's number of particles. That is 6.002 by 10 to the power of 23 particles. That's a lot of particles. Think about that number. That's too big a number to be used in calculations, so we use 1 mole as a surrogate marker for an Avogadro's number of particles. 1 mole of different substances all have the same number of particles. So 1 mole of any substance, same number of particles, an Avogadro's number to be exact, and particles are made of atoms. Let's take a closer look at an atom using carbon as an example. Every atom has an atomic number and a mass number. These two properties can be found on the periodic table of elements, and they influence how an atom interacts. Atoms are structured with the nucleus at the center, which is made up of protons and neutrons. The nucleus is surrounded by electrons organized into shells, and each shell can hold a specific number of electrons. All atoms desire the same thing, a stable relationship. What does that look like? An outer shell that has a maximum occupancy of electrons. The first shell around the nucleus can accommodate a maximum of 2 electrons. The second shell can accommodate up to 8 electrons, and the third shell can accommodate another 8 electrons max. We think a full set of diamonds is what we need for stability, but at an atomic level, what we really need is a full set of electrons. Let's use carbon as an example. It has an atomic number of 6. Its electrons will be organized so that it maximally occupies the first shell with 2 electrons, leaving 4 electrons on the outermost shell for a total of 6. To achieve stability, carbon can either lose 4 electrons and have a stable outer shell of 2, or it can gain 4 electrons and have a stable outer shell of 8. This is valency. Valency is simply the number of electrons an atom needs to gain, lose, or share to achieve a stable outer shell. Please note that valency is not the number of electrons on the outermost shell. Those are valence electrons. This is a common mistake that is made and leads to a lot of confusion. For a full explanation on how to determine valency of an atom, including the breakdown of the difference between valence electrons and valency, see the unit How to Read Valence at pharmacology.com. Now that we know how to derive the valency for our equivalent weight calculations, let's talk through atomic weight. Atomic weight is straightforward. It tells us the number of protons and neutrons in the atom. Protons and neutrons make up the nucleus of the atom. The nucleus of an atom is very stable in a chemical reaction. It is actually not involved at all. It is only those unstable electrons in the outermost shell that are motivated to gain, lose, or share to form a stable bond. All we have to do for the atomic weight is look at our periodic table for the larger of the 2 numbers next to the element. Now that we know how to derive both components needed for the calculation of equivalent weight, let's put it all together. 1 mole of any substance has the same number of particles, an Avogadro's number to be exact. Particles are made up of atoms. Atoms desire stability, which is a full outer shell. 2 factors influence how an atom will achieve stability, and that is atomic weight and valency. Equivalent weight is simply the way that we account for the differences in the influence of atomic weight and valency when atoms interact with and among each other. Using carbon as an example, let's work through some calculations. Carbon has an atomic weight of 12, that is the larger of the two numbers on the periodic table. It has an atomic number of 6, which means it's 6 electrons in its outer shell, 2 on the first shell and 4 on the outermost shell. To achieve stability, it will gain or lose 4 electrons. Its valency is 4, so its equivalent weight is therefore 12 divided by 4, which is 3. Let's try oxygen. Its atomic number is 8, so it has 8 electrons. The first ring will have 2 electrons. The second outermost ring will have 6 electrons. Oxygen will have to gain 2 electrons to stabilize its outer shell for a maximum of 8. Its valency is therefore 2. Its atomic weight is 16. Therefore, the equivalent weight is 16 divided by 2, which is 8. When carbon and oxygen interact to form compounds like carbon dioxide and carbon monoxide, we compare their relative interactions by using their equivalent weights. Equivalent weight is used in the calculation of the number of equivalents, milliequivalent concentrations, and osmolarity. Units for each of these calculations can be found at pharmacology.com.